this shows the two cans that I now have been testing. In fact, the one on the left is the inner can, and you can compare it with the one on the right, which is the outer can. It is the same can on the left that we used before, and inside there is a grate that we had before. You can see it in the bottom there, and if you look at the bottom, which I didn't really show last time, there it is. It has some very high temperature felt around the bottom, which acts as a gasket, and air can go right through the bottom there. Interesting to compare it with the height of the outer can. You'll see that it is a little bit lower, so that when air comes up for the secondary burn, that is the air that burns the smoke coming out of the top, it can come through the holes at the top, but it can also come over the top. So the updraft will draw some air through the holes, but if that's not enough, there'll be more air coming over the top. It then comes out of the hole in the top of the outer can. The can on the left, the one which has the fuel and is burning, that one has 100 millimeters diameter. That's 100 millimeters across. The hole in the lid of the one on the right is 70 millimeters across. That means it has about half the area, so that the flames are concentrated or squeezed into a smaller opening. Now let me show you some other things. The one on the right has got 3 screws for a pot stand, and it has a handle as before. It has holes around the bottom, and you'll see why shortly. Inside I took some baking foil, which many people use here, and I crushed it up, and then I stretched it out again so that it was all jiggly, and then I took a rolling pin and I flattened it, but not completely flat, and I used this to make a lining inside the stove. That acts as extra insulation, so it keeps more heat inside the stove. That's what I discovered, which is a useful step. Now there's one other thing here which I hope will work. I've not tried it many times, but I took a can which has got 70 millimeters of diameter, which is the same as the size of the hole. In fact, it's the most common size of can for food, like baked beans and all sorts of things like that. And there is the bottom of it. See that the bottom of it just about fills the hole, but it's got these other bits which are sticking up. If I drop it through that hole, you'll see that it's suspended, dangling down inside the big can, by probably 15-20 millimeters, and part of it, there are some little bits which look like little wings pointing inwards. Now this is to try to reduce the soot that come and tar that come out. It is actually very hot in there, and when the yellow flame comes up, it will hit that little inner plate. I'll call it a baffle. It will hit that baffle, and that will, I hope, stop the little particulates which are burning with the yellow flame. And it will also force them force all the wood gas to go around that plate and mix better with the secondary air coming up between the two cans. So I'll pause it there now and I'll fill the can. Right, now here is a sheet of aluminium. It is 540 millimeters by 270, so there's basically each half is 270 by 270 millimeters, and you'll see on the right there's a triangular hole in the middle, and if I zoom in I'll just move a lever. You'll see that I can control how much air can get through the hole. The lever is over here, and now let me turn it over. There it is. It's just a flat piece of steel. Steel is a bit more springy than aluminium, so it presses down, and there's a little plate there to cover the hole a bit better than the width of the steel. And when I move it, I can control how much air goes through. On the other side, I've done the same, but I've attached a little fan, and I can control how much air goes through that side with a little fan. You'll see that it stands on wood, and you'll see that the levers are arranged so that I can't bend them out of shape because they're in that slot. Right, now when you come to the top, the inner can has to be well located over that hole. So I made this disc and I twisted bits of it up, as you will see. So this inner can, it goes on there like that. It's not seating well. There, okay. It's seating well now, and it has the gasket underneath of that high temperature felt. And now the outer can, showing that, the outer can is made so that the hole in the bottom just fits nicely over the inner can, so that it can go on there like that. And now we have inside, you can see the fuel in the inner can and the outer can, and I can light the fuel, and you'll see there I have put this baffle in which should reduce the smoke. I'm going to take it off, I'll light it and then put the outer can on. So pause. Right, now you will see in the top here some darker pieces. These are pieces that I've soaked in white spirit, which we found in the previous videos tends to make quite a lot of smoke. Well, it probably will as I do this, but I'll light it now and then put the outer can over it. Yes, it burns up quickly, but you'll see, I think you can see that there is smoke coming up, quite a lot of smoke. Now let me put the outer can over that. Already the smoke is much less. So that's quite interesting. The smoke is much less there. And if I reduce the flow of air by turning the lever, I have this lever here. but really I want it to get fairly hot first, burn down a bit. There is a wind today. I think there's a danger that the wind could blow it out. It's much more wind than when I made the last test. Okay, we'll just leave that to settle for a while, and I will then so we'll pause now, and I'll put something on to on the pot. Right, it's burning, and the flame is fairly clear. It's not burning quite as hard as I expected, but I've got a pot with some water in it now. There it is. And it does now seem to be settling there. There may be a slight bit of smoke round the far side, I'm not sure why, but you can see that the flame was far cleaner. Right, let me put the lid on. Once the lid is on the pan, and it should, we make a note, it says it's 11 minutes into my video, and it's a minute past 5 o'clock. So I'll stop. Now it is starting to boil. You can see through the glass lid, so quite interesting. The flames look cleaner than we had with the other stove test. I've got it on full. I seem to have it there, but every so often some wind seems to disturb it, and then there is smoke. So I'm going to add a bit more water, and we'll see how long it will burn. It actually took about 8 minutes for the first lot of water to boil. I think that would be about 3/4 of a litre first that I put in, and I think it's now got a little over a litre of water in it. It is now about 16 minutes since I first put the pot on, and it is now boiling the second lot of water for the total there. It is now boiling the third lot of water that I've added, and it's about 20-21 minutes from when we started. I think the flame is dying down, which could mean that it's now mostly, yes, it will now mostly be burning the charcoal. It will be able to simmer on that for a while as the charcoal burns and gradually cools. It's on full air. I turned that up, but there is a bit of steam coming out still. A bit of steam. The amount of fuel that we put in was about 188 grams, and something like 65 grams were of the densified fuel, and the rest was the poor quality wood chip that I have had from tree surgeons and so on, and I think that is full of tar, and I've not yet managed to get the fire hot enough to deal with all that tar. It is now 35 minutes, and the water is still simmering quite strongly. That will be burning on the charcoal, but I want to end this, and I want to have a look at what's happened to the pot. So I'm going to take the pot off, empty it, and we'll look at the bottom. Well, it still looks like it's not so good. I think that is not so thick, but there's still quite a bit of tar on it. Now I'm going to take the outer can off and we'll have a look at the charcoal. There is the charcoal in the bottom. Some of it's going a bit white, so it's been burning on that charcoal, cooking on that charcoal. You'll see if I turn down the air, you'll see that the brighter areas go all less bright, and if I turn it up again, you'll perhaps see that some of it does brighten up again. Okay, so not very successful, but it shows hope, and it shows how some of my ideas have evolved. I have another can. This works on principle which does not permit the air. It does not permit any air to flow over the top, and in fact this is suspended in the can, and it allows total air control, the secondary and the primary air. This I think is going to be a lot more interesting. I did a test with it and it seemed to get a lot hotter, but I'm not sure I can control it.